this video, we are going to start our EC2 journey. This is going to be a mix of lab as well as theory sections. So, we will start exploring EC2 in AWS console, and as and when we come across a concept, I will give you more information on that. So let's get started. First, let us understand what an EC2 is. EC2 stands for Elastic Compute Cloud. Basically, EC2 instances are nothing but virtual machines that are hosted on AWS infrastructure. In AWS, there are thousands of powerful hypervisor machines hosted in all the regions and availability zones. These hypervisors, which host VMs, are managed by AWS and no users can access these. Let us say a user gives a command to launch an EC2 instance using AWS Management Console and EC2 service. Based on the location and some of the other preferences which we will study throughout this course, EC2 service will select a hypervisor and launch that EC2 instance for you. If the user wants to launch, say, 2 VMs or 2 EC2 instances, AWS is going to launch 2 VMs on that hardware based on the instance details that you select. So, in short, it is a simple mechanism of supplying the demand. If you get this fundamental concept, you are going to breeze through this section. Let's log into our AWS console. In the AWS console, let us go to EC2 service, which is under compute category. First, let's see what all is offered by this console. First, you have this Ec2 dashboard. It will show you the current and latest state of the resources that you have created, such as running instances, dedicated hosts, volume, elastic IPs, snapshots, and so on. This section is the entry point of the EC2 creation as it allows you to launch the instance that you want. This section shows you the service health, that is, it tells you whether the availability zones in this region is operating or not. On your left, you have all the options associated with EC2, such as events, tags, reports, and limits. This subsection is all about EC2 instances. This subsection is about the Amazon Machine Images or AMIs, which are used to launch the VMs, followed by Elastic Block Store or EBS storage options, which includes volumes, snapshots, etc. Then we have network and security. Remember that EC2 service creates secure and reliable virtual machines, so networking and security aspects are very important. Then we get into load balancing and auto-scaling, which we will learn in the next big section. And finally, some system management options. Now the fun starts. Let us launch our first EC2 instance. First thing first, it asks you to select an AMI. What is an AMI? Let's look at it in details. Quite simply, it is an information in the form of a template that is required to launch an EC2 instance. It includes a template for the root volume for the instance, for example, operating system or software packages, etc. It also includes launch permissions, that is, which AWS accounts can launch a VM from it. And it also includes information on which volumes to attach to the instance once that instance gets launched. You can launch your EC2 instances from AMIs which are available in AWS Marketplace, Community Repository, or you can launch one from your own. You can launch an instance from an existing AMI, customize the instance, and then save this updated configuration as a custom AMI. That is, instances launched from this new custom AMI includes the customizations that you made when you created the AMI. Back to the console, you can see that you can select the AMIs from AWS Marketplace, which has images that come with pre-installed commercial softwares. Of course, their prices will vary based on what all is included in the image. There are thousands of these to choose from. You can also select one from the community AMIs, such as the ones with Amazon Linux, CentOS, Debian, etc. As I mentioned, you can launch an instance using these AMIs, make your changes, and you can export the AMI as your own custom AMI, which will be available under My AMIs tab. More on these AMIs later, but for now, go to Quick Start. Now we are going to select this AMI. Let's see some important information here. First, It says HVM here as well as here. Virtualization type is HVM, that is Hardware Assisted Virtual Machine. There are two types of virtualization supported by AWS, HVM and para-virtualization. For the exam, remember that AWS supports both. However, for best performance, AWS recommends that you use HVM AMI. Another thing to note is the root device type, which is EBS, that is Elastic Block Store. You can also have AMIs with Instance Store as the root device type. If you go to Community AMIs, you can select AMIs with Instance Store as the root device. Finally, this is the AMI ID. You might see a different one than mine, which is okay. It gives you information about the AMI here. Now click Select. On the second step, it is asking you to choose the instance type. Let's see what all are available. Click Filter by. You can see General Purpose, Compute Optimized, GPU Graphics, GPU Compute, Memory Optimized, and Storage Optimized. Now, I want you to click here on Learn More. It will show you more information on the instance types. If you click on each of them, you will realize that General Purpose are represented by T, Compute Optimized is denoted by C, Memory Optimized is denoted by X, Accelerated Programming is denoted by P, and Storage Optimized by H. You do not need to remember these by heart, but in the exam you might see the model names such as H1.2x large mentioned. With that, you might immediately come to know that this is a storage optimized instance. It might help you in the exam. Now let's see what all information is given here. Family and type we just saw. vCPUs are virtual CPUs of the instance. More the better for performance and computing. Memory. Instance storage can be EBS only, or you can stripe SSDs together. EBS optimized means that the instance provides you with additional dedicated throughput for EBS input-output. So, in short, you will get a better performance if the instance supports this option. Note that not every instance supports this. Network performance indicates if the data transfer over the network is faster or not. The more, the better. We will learn about what a placement group is in the next step of the EC2 creation. Finally, whether the instance supports IP version 6 or not. Before we go to the next step and configure the instance details, I'm going to stop this video here and we will continue in the next one. Thanks. In the previous video, we learned about the Amazon machine images. We selected Amazon Linux AMI. We also learned about different types of instances. We are at the step 2 of the EC2 creation. Let's select a general purpose T2.micro type instance, which is a very small utility instance with one virtual CPU, 1 GB RAM, etc. It is also free tier eligible, so click on Configure Instance Details. On this step, we are going to customize the instance per our need. First, you can select the number of instances to launch. Remember that all of them will have the exact configuration. AWS offers different purchasing options. Since this is a very important topic for the exam, let us take a look at it in detail. In general, AWS offers 6 purchasing options: on-demand, reserved, scheduled, spot, dedicated host, and dedicated instances. The on-demand instance option is quite simply a pay-as-you-go type. You purchase the VMs as and when needed. You pay the current listed price per usage. This is the costliest option compared to all others. This purchase option is suitable for situations where you are not sure about the capacity needed beforehand. For example, you might go for an on-demand instances when your application has sudden spike of traffic, or you are not sure about the duration for which you will need it, or you are just experimenting or doing research and development and do not want any prior commitment. The reserved instance is the proactive type. You purchase the virtual machine beforehand. Earlier and longer the period you reserve them, more it will save you the money. Since you are reserving or committing to buy, you get a significant discount from Amazon Web Services. The instances can be reserved for a term between 1 to 3 years. This purchasing option is suitable for situations where you are aware about the capacity needed. For example, you might reserve the minimum number of instances needed to run your application smoothly. In scheduled instances, you basically purchase instances that are always available on the specified recurring schedule for 1 year term. This is give me if available for this price type. This is a significantly cost-saving option. In this option, you bid for the unused EC2 instance capacity of AWS. That is, you tell AWS that you are prepared to pay X amount if EC2 instance capacity is available. If the actual price of that EC2 instance class becomes equal or less than the bid price, the instances get assigned to you at your bid price. However, if the actual price increases than your bid price, your instances may get terminated with a half an hour's notice. So this option is little risky, and hence you can see a little exclamation mark on the icon, since you might lose the instance in a short notice. Now note that you will not be charged for that partial hour in which the instance was terminated. This is very important to remember for the exam. For example, let's say you bid for C1X large instance for $1 per virtual machine's usage. If the actual or current spot price is equal or less than $1, you will get the instance assigned to you for your bid price, that is $1. If you use the instance for say 5 hours and halfway through the 6th hour, that is total 5.5 hours, the actual instance price becomes more than $1. Your instance gets terminated within half an hour's notice, but you will not be charged for that 6th hour. So you will be charged only $5 and not $6. Now, there are few concepts that you might come across in the exam. Spot instance pool, which is a set of unused EC2 instances with the same instance type, operating system, and in the same availability zone. Your instance will be one of these. Spot price is the current hourly price of the spot instance. Spot instance request is nothing but your bid or the price that you are willing to pay for a spot instance. In Spot Fleet, basically you specify the criteria of the instance, and then the Spot Fleet selects the spot instance pools that meet your needs and launches spot instances. And finally, and very importantly, spot instance interruption occurs when Amazon EC2 terminates, stops, or hibernates your spot instance when the spot price exceeds the maximum price for your request, or capacity is no longer available from Amazon Web Services side. Now let's take a look at the dedicated host and dedicated instance purchase options. First, let's see what happens when you launch a VM without a dedicated instance or host. When you launch an instance on AWS, your VM is hosted on an underlying hardware or hypervisor that is hosted by AWS. User cannot access this hardware. There are many hypervisors, and let's say your VM gets launched on hypervisor A. This hypervisor may host VMs for other customers also. Even though the VMs may not interfere with each other, they are there. Hence, this is called shared tenancy. If you reboot the VM, it will be launched on the same hypervisor A. But once you stop and restart the VM, your VM may not be launched on the same hypervisor A. It could be launched on hypervisor B, which is still a shared hypervisor and may host instances for other customers. In dedicated instance option, your VM will be launched on a hypervisor that is dedicated to you. That is, the hypervisor will not be hosting any VMs belonging to the other customers. Let's say there are two such dedicated hypervisors for you, C and D. Let's say the instance was launched on C. If you stop and start the VM, your VM will be rehosted in one of these two. So, even though you're assured that your host hypervisor is not shared with others, it is not guaranteed that the VM will be launched on the same hypervisor, that is C. It could be launched on D, which is still dedicated to you. But in dedicated host option, it is always guaranteed that the VM would be rehosted on the same hypervisor machine, even if you reboot or restart it. This is very important because if your application uses hardware-tied license software, you can bring your own license and it can be tied to your dedicated hardware or the host. Note that you will not notice any performance issues whether it was shared, dedicated instance, or dedicated host option. Back to AWS console. In Network and Subnet, you can select the Virtual Private Cloud or VPC and a subnet inside it. We will see VPC in details later, but let's take a look at this concept. On AWS, first you define a VPC, which is just an IP range. This VPC spans multiple availability zones. Then you define subnets inside the VPC, ideally a public subnet and a private subnet. Then you will create instances which are accessible over the internet in public subnets and instances which are more secure and inaccessible to internet, for example database servers, in the private subnet. For now, just keep both as default. With this option, you can leave the decision of assigning public IP address to your instance to the setting on the VPC. This we will see in VPC section as well. Just keep it default, which is enabled. We will learn about the placement group later in this course. Now, we know that in order to access AWS resources, you need to create an IAM role. We are not going to access any other AWS resources like S3 bucket using this instance. So just keep it as is. But if you wanted to, you could create the specific role and assign it here. With the shutdown behavior option, you can either stop or terminate the instance if you choose shutdown option from the OS on that instance. Remember that if you stop the instance, you do not lose it. You are not charged for the usage either. However, if you terminate the instance, you will lose the instance as well as you will not be able to access it again. This termination protection option saves you from accidental termination of the instance. So, you will not be able to terminate the instance if this flag is checked on. You need to disable it before you can terminate it. With this option, you can enable the monitoring of the instance using CloudWatch metrics. I'm going to enable it. Remember that it will cost you money, so you can disable and just follow me if you want. Then we have a tenancy option here. As mentioned during the purchasing options, you can launch the instance on a shared host, launch as a dedicated instance, or launch it on a dedicated hardware or host. T2 or T3 unlimited. These micro instances are burstable performance instances. These instances have ability to burst to a higher level when required by your workload. Enabling this will enable the instances to burst the performance for as long as needed. You can just leave these options unchecked. In advanced details, the user data is used for bootstrapping the instance. Let's say you want to run some script as soon as the instance gets launched. You can do that via this option. For example, you can install some packages or updates or set up the instance as a web server, etc. To test this, just copy the content of the script given along with this video and paste it here. What this is going to do is first, it is going to elevate the permissions to the super user. It is going to then install the Apache web server. It is going to write a simple HTML script and it is going to create an index.html page in your web server, and then it is going to start the Apache web service. So as soon as this instance is created, you can go to the public IP address of this instance and it should already have created the index page which says welcome to the WizLabs AWS course. Now before we go ahead and add the storage to this instance, let us take another break here. I'm going to stop this video and we'll continue in the next one. We have set up the instance details. Now click on Add Storage. Here you can set up volumes. A volume is basically a block level storage device that you can attach to a single EC2 instance, just like any other hard drives. They are flexible in the sense you can dynamically increase size, modify provisioned IOPS capacity, and change volume types on live production volumes. IOPS is basically input-output operations per second. Now, by default, it has set up the root volume. The snapshot of this volume gets stored in S3 by AWS. You cannot access this as this is maintained by the AWS themselves. The size of the volume should ideally be between 4 to 2047 GB, that is gigabyte. Let us take a look at the different volume types based on the performance that they yield. There are three types of the EBS volumes: general purpose solid state drive, provisioned IOPS solid state drive or SSD, and magnetic hard disk drive, that is HDD. Let us see some of the basic differences between the SSD and HDD. In general, solid-state drive backed volumes are optimized and are more suited for applications that require frequent read-write operations with small input-output size. So, if IOPS or input-output per seconds is the main criteria or requirement, you should be using solid-state drive rather than hard disk drive. Whereas the hard disk drive backed volumes are more useful when the throughput, which is measured in megabits per second, is more critical than the IOPS. In general, solid state drives are costlier than hard disk drives. Now let's take a look at the general purpose SSDs. As the name suggests, it is more suited for general purpose where it balances both cost and performance. It supports a variety of workloads. It can be used as the root volume of EC2 instance. This is mostly used for low latency interactive applications and development and test environments. It is important to remember that it provides baseline performance of 3 IOPS per GB. Note that this is gigabyte, not gigabyte. 1 gigabyte is closely equal to 1.074 gigabytes. The minimum IOPS it provides is 100 and maximum is 10,000. In provision throughput SSD, if your application demands extensively high throughput and low latency, you should use this volume type. It is most suited for applications that require sustained IOPS performance or more than 10,000 IOPS or 160 megabits of throughput per volume. It is used in scenarios where database workloads are very high. It is important to remember that it provides baseline performance of 50 IOPS per GB of volume. The minimum IOPS it provides is 100 and max is 32,000. The magnetic hard disk drives are older generation volumes that are backed by magnetic drives and are more suited for workloads where data is accessed infrequently. It is suited for applications where low-cost storage for small volume sizes is more important. These volumes deliver approximately 100 IOPS on average and maximum throughput is 90 megabits per second. Now there are some other hard drive disk options that are available and which can appear on the exam. The throughput optimized one is used for applications that have frequently accessed throughput intensive workloads. This is a low cost hard disk drive option. The max throughput per volume is 500 megabits per second. The other one is the cold hard disk drive, which is used for applications that have less frequently accessed non-intensive workloads. This is the lowest cost option. The maximum throughput per volume is 250 megabits per second. Now note that both these hard disk drive options cannot be used as the root volume for the EC2 instance. Back to the AWS console. As I mentioned, the only disks that you can use as the root volume are general purpose SSD, provision IOPS SSD, and magnetic. You can select the general purpose SSD. The baseline performance is 3 IOPS per gigabyte with minimum 100 and maximum 10,000. So if you select as 40 gigabytes, The IOPS that you are going to get for baseline is 120. However, if you select a very large size, let's say 4000, the maximum IOPS that you're going to get is 10,000. If you select provision IOPS as the root volume, as you can see, the maximum IOPS that you can get is 32,000. The delete on termination flag indicates whether you want to delete the volume upon terminating the instance. Note that the data stored on EBS volume is persistent even if the instance terminates. Let's say you have an instance and a volume is attached to it. You can always detach the volume from one instance and attach it to another. So, even if the instance terminates, the volume can still be available. But if this flag is not checked, you will lose the volume upon the instance termination. Also note that instance to volume is a many to one relationship. That is, you can have many volumes attached to a single instance, but you cannot attach one volume to many instances at the same time. You can detach it from one instance and then attach to other. Now let us study the encryption of the volume in details. When you encrypt the EBS volume, the following types of data are encrypted. The data at rest inside the volume, all the data moving between the volume and the instance, all the snapshots that are created from the volume, and all the subsequent volumes that are created from those encrypted snapshots. Also note that the volumes created from the encrypted snapshots are automatically encrypted. The volumes that are created from unencrypted snapshots are automatically unencrypted, or they are left as unencrypted. In the AWS console, you can add one more volume, and you can notice that it has given you the option whether to encrypt this volume or not. And as I mentioned, to do this, you will require key management service configuration. For now, just delete this extra volume. Now let's click Add Tags. We have already learned about tags and how it is extremely useful for management of the resources. Here, you can add tags which are key value pairs. Note that you can add a maximum of 50 tags per instance. You can click to add a name tag and give it a name. You can add more tags if you wish. As mentioned here, these tags will be applied to the instances as well as the volumes attached to those instances. Click Next, Configure Security Group. Now this is one of the most critical concepts in overall AWS course. If you clearly understand security group and some of the other network and security topics, it will not only help you in the exam, but immensely help you solving any architectural network issues on Amazon Web Services. We are going to see security groups in detail during the video on Virtual Private Cloud or VPC, but let me explain it a bit here. As I mentioned before, EC2 instances are launched inside a VPC and inside subnets. During the launching, you need to protect the instances by applying a security wall, just like a Windows firewall. While configuring this firewall, you are basically controlling the traffic that is coming in and out of this instance. Now, there are a few important points to remember with respect to the security group. The security group basically protects the instance by applying a security wall of rules, which is like a firewall. It also controls the traffic coming in and going out of the instance. You can configure rules on this security group using a type of request, that is TCP, UDP, SSH, etc., protocol, which could be TCP, UDP, ICMP, etc., port number or range, and the source of traffic. You can also give this rule some description. Note that by default, all the traffic is denied by the security group. You can only define allow rules. That is, you start opening the doors for the traffic and the source that you want. An extremely important point is that if you allow traffic of a particular type from a source into your instance, the outgoing traffic is allowed automatically. That is, you cannot define just a one-way traffic. Hence, security groups are called stateful. That is, if you allow incoming traffic, the corresponding outgoing traffic is allowed automatically. Another important point to remember is that security groups work at the instance level, and you can add multiple instances under one security group. As soon as you add an instance to a security group, the security group rules are applied to the instance immediately. Now let's go ahead and create a security group. You can name it WizLabs Security Group. Give a description. Type, you can select SSH. Now for the source, you can select custom, anywhere or my IP. Let's select my IP so that only you can SSH into the instance. And you can give some description. I'm going to keep it as a blank. You can add some more rules, for example, HTTP. You can use anywhere or my IP. Click review and launch. On this screen, you can read and verify that everything is okay and hit launch. Now to log into your instance, you must create a key pair. A key pair consists of a public key and a private key. Let us understand this concept. Amazon EC2 uses public key cryptography to encrypt and decrypt the login information. The public key cryptography encrypts the password using a public key, then the recipient or the user uses the private key to decrypt the data. This public key is maintained by AWS, the private key is maintained by the user. This public and private keys together are called as key pair. Back to the AWS console. Here, you need to specify the name of the key pair when you launch the instance and provide the private key when you connect to the instance. We do not have any key pair, so let's create one. Give it a name. You can also download this key pair. If you are a Windows user, you will have to download PuTTY to be able to SSH into this instance. So let's go ahead and launch this instance. If you click on the view instance, you can see that the demo instance is getting created and its instance state is pending at the moment. While it is getting created, let's go ahead and download the PuTTY. Now go to this website www.putty.org and download the PuTTY. You can download the MSI installer, and based on whether your machine is 32-bit or 64-bit, just download the corresponding MSI and go ahead and install it. Once PuTTY is installed, just open the PuttyGen. So I have opened the Partition Key Generator. What it is going to do is it is going to load the private key that we just downloaded from our AWS console. So go ahead and load it. You have to select all files. Select the PEM file. It is going to say that successfully imported the foreign key. And now we need to save this private key. Say yes. The file that will be saved will have the PPK extension. So go ahead and save as Windows key. Close the PuTTY key generator and open the actual PuTTY application. Now to select the host name, you have to go back to the AWS console, click on the instance and copy its public DNS. Now note that you can either use the public DNS or you can also use the IPv4 public IP address to SSH into this instance. I'm going to select the public DNS. Go back to PuTTY. Since this is an Amazon Linux machine, the username that we'll have to use is the ec2-user. Type @ and paste the DNS name that we just copied. Now go to connections. Under that, click on SSH, expand it, click on authentication and select the key that we just created, which is windowskey.ppk. Open it. It is going to ask whether do you wish to continue. Just say yes. And there you go. It has successfully SSH'd into our instance by using the username as ec2user and the Windows key that we just created. Now, if you remember, while launching this instance, we had used some bootstrapping script where we installed the Apache web server and created an index.html file for our web server. Let's see if that worked. Let's go to the AWS console and copy this public IP address, or you can just select it, right click on it and say go to. And there you go. Our web server is successfully created. In the previous video, we successfully created an EC2 that was launched as a web server. Just in case, if you are not able to connect to the web server, open the putty and SSH into the instance. The username would be ec2-user at and paste the DNS of the instance. Under connection, go to SSH, authentication, and select the Windows key that we saved. It should successfully SSH into this instance. Just check if the HTTPD service is running or not. Just run this command sudo service httpd status. Now you can note that currently this service is inactive and that's why you're not able to connect to the web server. So let's start the HTTPD or the Apache web service. Type sudo service httpd start. Just to ensure that the service is running, go back to the status and now you can see that the Apache web service is running. Go to your instance in the web browser and refresh it. And you should be able to connect to the web server. Now, before we start looking into the EC2 properties and start managing it, the one thing I wanted to point out is that since this is a Linux instance, you can find the public key content at the SSH authorized keys location. So type cd root. You need to get into the .ssh directory. So first locate it, type ls or ls-a. This will list all the hidden directories as well. And you can see there is a .ssh directory. Just get inside it. Inside this type ls. You can see there is a file called as authorized keys. Just open that using nano. Here you can view the actual content of the public key that was used as part of this key pair. So just remember that the public key gets stored inside a directory of the EC2 instance. Now let's go back to the AWS console. Here you can see all the properties belonging to the EC2 instance, such as name, instance ID, instance type. Very much all of them are self-explanatory. In the description tab, it shows some of the same properties. It also has information about the root device. It also has public DNS or domain name system information. If you open this DNS in a web browser, it will take you to the web browser's homepage. If you have your own domain, you can point your NS records to this DNS. Now note that since it was launched in a subnet that was public, it has been automatically assigned a public IP address. However, the other EC2 instances that are launched in the same subnet can communicate with this instance using its private IP address. In fact, the instances that are part of VPC peering can communicate using this private IP address. We will learn about VPC peering in a separate section. Now note that I have enabled the detailed monitoring. It also has HVM as the virtualization and default or shared tenancy. In the status check tab, there are two status indicators. System status check indicates whether the underlying hardware or the hypervisor on which the instance is hosted is properly working or not. If this check fails, it indicates that there is a problem with the underlying hardware or power or networking. AWS recommends that you simply stop and restart the service. Remember that it will make it launch on another hypervisor. We learned this in a previous video. If this does not solve your problem, just replace this instance with another one. The instance status check indicates whether there is any issue with your instance. It indicates whether the operating system on your instance is accepting traffic or not. If this check fails, AWS advises that you just reboot the instance so that it can be launched on the same hypervisor. Currently, both checks are getting passed, so there are no issues. The monitoring tab shows different CloudWatch metrics. Some of the most important metrics are related to CPU, disk, network, and status check. Remember these metrics of EC2 if possible, especially if you're attempting sysops administrator exam. The tags, of course, will show you the current tags on this instance. You can add or delete any tags that you wish. Now, if you click on Actions, it has some interesting options. The Connect gives you the steps that you can follow to SSH into this instance. If you are using Mac, connecting to this instance is very easy. You can just use the terminal. But if you are using Windows, to connect to this instance, you have to use PuTTY. Launch mode like this will help you create more instances with the identical configuration and settings. So click on it. It will use the same AMI details, instance type, security groups, other instance details, storage, and tags, and will allow you to launch more instances. Using the action, you can also change the state of this instance. You can stop the instance, reboot it, or finally terminate it. Some of the other settings that you can modify is you can add or edit more tags. You can attach this instance to an existing autoscaling group, which we will see in the next section. You can attach and replace the IAM roles. You can change the termination protection settings. Currently it is disabled, but you can enable it. You can also view and change the user data. Remember, user data means the bootstrap script that we used. So you can go ahead and change it here. You can also change the shutdown behavior, whether you want to stop it or terminate it. Since this is a T2 micro instance, you can change it to T2 unlimited, or you can change it to T2 T3 unlimited. You can also get the system logs, and you can also get the instance current screenshot. We will learn about image options in the next video. In the networking settings, you can change the security groups. You can also attach a network interface. A network interface is a component or a virtual network card that you can attach to an instance and detach from it so that it can be reattached to another instance. A network interface has following properties or attributes. A primary IPv4 address from the IPv4 address range of your VPC, one or more secondary private IP addresses from the IPv4 address range of your VPC, one elastic IP address, that is IPv4, one public IPv4 address, one or more IPv6 addresses, one or more security groups, a MAC address, a source and destination check flag, and a description. Now you need to remember that every instance in a VPC has a default network interface, which is called as primary network interface, that is denoted by ETH0. You cannot detach this network interface from the instance, but you have the ability where you can create and attach additional network interfaces. And as I mentioned, this is extremely useful if you wish to have multiple private IP addresses for your instance. Change source and destination check. This concept may not make sense at this moment. It will be covered during the video on VPC, so just ignore it at this moment. Using manage IP addresses, you can assign new IP addresses on each network interface. As I mentioned before, it already has a default one. You can add new ones based on your requirement. In this video, we learned about some of the most important properties of EC2 instance. It is very important that you play around with these properties. Try rebooting and restarting the instance. Observe the different metrics. Hope that you are comfortable with launching and using the EC2 instance by now. In the next video, we will dive deep into other EC2 related important topics. Thank you.